So I want to start today by simply reviewing what we did on Friday, percent of a number, and then what I'm going to do is give you about 5 of them that you can do on your own paper, and then you can write in your answer. And I won't put the answer in this video, so once you do this, you'll just have to wait until I've graded the ed puzzle that you're going to be doing with this to see how you did. And we'll review it in class as well on Tuesday. But the first one is 60% of 30. Now, if you remember, the way we set it up is this percent turns into 60 over 100. And that is times. The 30 becomes 30. It's 30 as a whole. So we write it in a fraction as 30 over 1. 60 times 30, if you're not sure, you can just do it on the side, as I'll do here for you. So that becomes 1,800 over 100. Now, if you're simplifying this, then we'll take 1,800 over 100. You divide them both by 18. Sorry, you divide them both by 100, and you will end up with 18 over 1. If you use the method that I taught you to cheat, we match the zeros up. Those zeros are going that way. If not, you can divide 1,800 by 100, divide 100 by 100, and you end up with 18 over 1, or 18. So the answer that you would put in is 18. Okay, so the next one that we'll be doing will be 10% of 50. Now on Edpuzzle, I'll pause the video and give you a chance to do this one and answer it. And now the next one will be 80% of 30. It's a good number. And now let's do 90% of 40. Keeping in mind, 90% is very close to 100%. So that should give you an idea of what your answer is going to be close to. And now let's do 30% of 30. Now be careful. Don't just type in the answer, the number 30, because that is not the correct answer. And for your last one for review is 15% of 20. And now we're going to move into lesson 25. Lesson 25 is finding a fraction as a percent, or writing a fraction as a percent. We may have done some of this already, so this might be a little bit of a review for you here. Now this first part is asking us to do a model. I'm not going to do that part right now because we've been focusing a lot on the actual computation, and we're going to continue working with that. So we'll read this part here, the first part here, and then we won't use the model for now, but we'll do the other two questions. Okay, so Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. We're not going to worry about the models. We're going to give the reasons. And models can include a tape diagram and all that. We're not going to worry about that right now. What we are going to do is just to skip down here to the question. How is the fraction of cars related to a percent? So first off, let's talk about what the fractions of the cars are. So if we're going to do the cars, we'll do the cars up here. How's that? Make that be our workstation. We're going to do, if we're finding percents is a part to whole relationship we talked about. So we want to find out the part to whole in this situation. And the part in this case would be, we're trying to find the cars, would be the 3 cars. So 3 cars. The whole would be the total number of vehicles here. And so if you count the cars plus the trucks, then we have 3/5 cars out of all the vehicles together. So if we want to find out how this fraction of cars is related to the percent, well, we know that 3/5 is the fraction. If we want to get it to a percent, we need to get it to 100. So we're very familiar with how to do this. How do we get from 5 to 100? If you're not sure, you can simply divide 100 by 5. And then you'll get the answer of 20. Sorry. So what that means now is 5 times 20 is 100, and so 3 times 20 is 60, and that will equal 60%. Okay. Another thing it asks is what other fractions or decimals can represent 60%. And so we know that 60% means 60 out of 100. We can start at 60 out of 100, and we can simplify it to 3/5. We can simplify it to, by dividing by 10, 6/10, and then 3/5. Those all represent that. We can also represent it with a decimal, such as 0.6 or 0.60. Okay, let's keep going. Okay, so example 2 is on the next page, and I apologize, I don't know what page you guys have. Just remember that it's lesson 25. So I think it's around 108, 109, maybe even 110. But my numbers are off from your numbers, so you have to look now at example 2, where it says, a survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part-to-whole fraction for comparing happy participants to the whole. So that's going to be our, recognize this? These are ratios too. So we're looking for a part-to-whole relationship to compare happy participants to the whole number. Then write a part-to-whole fraction, again, of the unhappy participants to the whole. And what percent were happy with their job and what percent were unhappy with their job. So let's start with the first one. And the happies, it said that there were, an overall score was given. 300 of the participants were unhappy. So we're going to put those here for unhappy. And then 700 were happy. So we're going to do 700 here. If we're looking at the whole, how many of them were all together? We're going to add the 700 and the 300. So that would be 1,000 total participants. Okay, so that's our part. That's what we were talking about before, part to whole. And here is our other part to whole. One part of them is happy, and the other part was unhappy, and the whole was the total number of people that were surveyed, were asked. Sorry. So, to find out the percent, we need to make our equivalent fraction, and we need to make it 100, because anything over 100 will get us our percent. Now, that means we have to get from 1,000 to 100. So to get there, we're going to need to figure out what we divide them both by. 1,000 divided by what will give me 100. Now hopefully you're taking a good guess on this to say 100 times what will give me 1,000, and your guess might be times 10. So let's try it. And there you have it. So 1,000 divided by 10 will give us 100. Now you may already have known that, but not everybody does, so I wanted to show it to you. We're doing the same thing here. To get from 1,000 to 100, we're going to divide by 10. So 700 divided by 10 will equal 70. and 300 divided by 10 will equal 30. Now they'd like us to show a model to create an answer. To show that, I think we can just do something we haven't looked at in a little while, but a double number line. So let's do a double number line here. I'm going to draw one here, and I'll pause it a minute so I can just draw it for you. So for the top of it, we will make it our percentages. So 10%, 20%, and on the bottom, we're going to do it by increments of 100. So 100, 200, and that's just because it's going to get us to 1,000 faster, and it will match up correctly here. Okay, so the ones who were unhappy would be the 30%, which turned out to be 300 people. And the ones who were happy, is that right? Would be the 70%, which would then be 700 people, which was the number that they gave us, the 700 and the 300. So that's just reviewing back double number lines for us. Okay, let's scroll down and look at exercise number 1. So exercise 1 says, Renita claims that a score of 80% means that she answered 4/5 of the problems correctly. She drew the following picture to support her claim. So we have columns, we have 1, 2, 3, 4, 5 columns. And she circled, she highlighted 4 of those 5. She wants to see if this is correct. So what we can do to prove to her if it's correct is first take the 4/5, create an equivalent fraction that will get us to 100, which we learned from previously that times 20 will bring us to 100. So times 20 here, that would be 80. And that we know can then be converted to a percent by just writing 80% because it's 80 out of 100. So is Renita correct? Yes, she is. And we use some computation with numbers. Below it says, how could you change Renita's picture to make it easier for Renita to see why she is correct or incorrect? So I could change a picture so that there is a percent scale drawn to the right side showing 20%, 40%, but I could also change the picture so that there are 10 strips with 8 shaded. So I could basically double this if I wanted to, and I'd have to double the shaded portion as well, and that could show her. That would bring us our 8/10 that we've talked about before. So that's how we can answer that. All right, let's go on to number 2. So exercise 2 is showing us what in essence is a double number line, just with a line that connects them. So it looks kind of like the fraction bars or the shape diagrams we've had, but the numbers are written differently. So we're going to treat it like a double number line. Use a diagram to answer the following questions. It says 80% is what fraction of the whole quantity? So if we look where 80% is, that's here. And so that is 4 out of, and then the whole quantity, because the 5 is at 100, 4/5. Okay. 1/5 is what percent of the whole quantity? So that would be looking at the 1. So this makes it nice and easy to be able to fill in the answer. That's 20%. 50% is what fraction of the whole quantity? So if 40% is at 2, then 50% will be between 2 and 3. And so we would put it right about here, and that would be about halfway from 40 to 50. That would make it 10. If you look at the bottom, going from 20 to 40, from 40 to 60 and 20 to 40, these are going in increments of 20. So this number, if we cut it in half, would be just 10%, and that puts this at the 50% mark. So between 2 and 3, halfway would be 2, and then we go halfway, 2.5. So what fraction is 50% of the whole quantity? That will be 2 and 1/2. We could say 2 and 1/2 out of the whole of 5. We could also write it as 2.5 out of 5. So let's go on to exercise number 3 now. Oh, before we do that, we have to say 1 is what percent of the whole quantity. So 1 would be, if we are correct, 5 over 5, because the quantity went up to 5. So 1 whole would be 5 over 5. And then the percent of that is 100%. Okay, now let's go to the next problem. Okay, Maria completed 3/4 of her workday. Create a model that represents what percent of the workday Maria has worked. So let's just focus on, I think sometimes models confuse people and they get kind of frustrated with it. So I want to just focus instead on what percent of her workday does she have left. So let's use our workspace up top to determine what 3/4 of her workday would be. So 3/4 is our part to whole relationship. So part would be 3. The whole would be the 4. We want to get to a percent for the whole workday. The whole workday is cut into 4 pieces. If we had all 4 pieces, it would be at 100%. So the whole is 100. How do we get from 4 to 100? If you work with money, then you could say 24 times 25 cents is 100. So 3 times 25 is 75. So 75%. 75% refers to how much she's completed. So she has completed, 75% of her workday. So 75% is completed. Once we have percents, we can then answer what percent of her workday does she have left? She has 25% left. We're not going to worry about the model at this point because I want to focus on some other things. Exercise 4 now talks about Matthew, who's completed 5/8 of his workday. So this becomes a little more complicated when we say 5/8. There's our part, there's our whole. The whole workday is cut up into 8 parts. We want to get it to 100. The problem is it's not so easy, is it? There are a few ways we can do it. We want to say 8 times what will get us 100, and we know that quite often students will say, there's nothing, you can't do anything. But we could. There's a few things that we could do. So let's do something that's fairly easy, and let's change it to a decimal. If we change it to a decimal, we can go from decimals to percentages pretty quick. So let's take 5 and divide it by 8. That's how you change a fraction to a decimal. I know we've done this before, but you may have forgotten. So 5 divided by 8, we're going to stop by putting our decimal. It's already at the end here, so we're going to put it at the end here and at the top. And then we're going to say what times 8 equals 5, and that will be 0. And we're going to make a 0 appear as we need it. So our new number now becomes 5, bring down the 0. And I know that 5 times 8 is 40, but 6 times 8 is 48. So I'm going to say 6 times 8 and say 48. 50 take away 48 is 2. And then I'm going to bring down my other 0. And then say what times 8 will give me 20. Oh, I know that 3 times 8 is 24. So that's too much. 2 times 8 is 16. So 2 times 8 is 16. And 20 take away 16 without even having to borrow anything, I know is 4. going to make one more 0 appear. Now I know that 5 times 8 is 40. So my number is 0.625. However, I wanted to get it into hundredths, and if I write 625 over 100, that's going to be kind of wonky for us. So I could do that, but I can also do this. I can say, let's look at the one we want. We want the hundredths, that's tenths, hundredths. We want this number here. But as you remember, we look at the 5 to determine if we're going to go up or leave it alone. And since it's 5 and above, we're going to go up from 62 to 63. This number then becomes 63 over 100, or 63%. That's a quick way of doing it. Taking that 0.63, and this is where it says, how can you use a decimal to get the percent of the workday that he's completed it? You can do it that way. You could also say, however, if you wanted to be exact and precise, we could take this 6.625 and say 62.5%, which can be written as 62.5 or 62.5%. Both of those are acceptable answers. So you can have a percent when we're talking about the halfway mark, because we have a base 10 system and our halfway mark would be 5. So here we are halfway to the next number, which is 3. So you could write 63%, but if they wanted it to be exact, we could also write 62.5 or 62.5. Okay, we're going to stop there for now, and I'm going to have you do a few more. Of turning a fraction into a percent. So exercise 5 says complete the conversions from fraction to decimal to percent. So we'll start with 1/8, and I'll help you with 1/8. That is by saying 1 divided by 8. So if we do on the side 1 divided by 8, remember that the fraction bar means divided by. I can see that there's a 0 at the end here, so there's a 0 at the end, a decimal point, not a 0. We'll put the 0 in after. We'll put the decimal point right up there because it's already at the end. Now we can put our zeros in, because what times 8 equals 1 is 0. And so what times 8 will give us 10 or close to it? That would be 1. 1 times 8 is 8. 10 take away 8 is 2. Make another 0 appear and bring it down. 2 times 8 I know is 16. 3 times 8 is 24. So again, we're going to go with 16. This is very similar to what we just did. 20 take away 16 is 4. Make another 0 appear and bring it down. And we have 40. And so 5 times 8 is 40. Now we have the same number that we had before. So the decimal would be 0.125. If we're going to do the percent for this, we know that it's 12%, but then half of another one. If I was drawing the 100 boxes, I would do a tenth, and then two boxes, and then half of a third box. And that would be 12.5%. So as a percent, we can write this as 12.5%. Okay, so why don't we do the next one? Let's start with 35 hundredths, and let's give the fraction for that. Okay, and then let's do the percent for 35 hundredths. So the next one is 84.5%. What's the decimal for that? And to do this fraction, you could write 84 and a half over 100, and then we could bring it to 1,000 by multiplying it by 10. And if we do 84.5 times 10, remember you line up the numbers, not the decimals, you would have 0, 0, 0. And then we have to bring it over 1. We would have 845 over 1,000. And that would be the fraction for that. Okay. 325 thousandths, what's the percent for that one? And what is the fraction? And then 2/25. Why don't we do the percent for that one first, and then the decimal. And that's all we're going to do for today. On Tuesday, we're going to review these. We'll see how you did. And we will, don't worry about it if you got some of these wrong here. These won't count against your grade in a bad way. I just want to see what you're able to do. And when we come together on Tuesday, we're going to do some more problem solving with the part-to-whole relationship and turning things into percentages to get ready for our assessment, which will start on Wednesday, Thursday, and Friday of this week. So you'll have plenty of time to do well with this. Don't stress. Do your best is all I've ever asked. Thanks.